Hello and welcome back. We're going to look at lesson 3.3, expanding our concepts of probability. In this lesson, we're going to look at two of our basic rules of probability, which we've sort of introduced through other topics in 3.2. So if there were things in 3.1 and 3.2 that you were just not sure of, hopefully we can expand that understanding in this lesson. So the first rule is called the multiplication rule. And I mentioned this in 3.1, but it says if A and B are two events defined on a sample space, then the probability of A and B, it can be written like this. We introduced this rule, we introduced this formula right here in 3.1, the probability of A given B. And so the probability of A and B can be found by this, the probability of B times the probability of A given B. The probability of A given B equals the probability of A and B divided by the probability of B. If A and B are independent, then the probability of A given B is just the probability of A. Then probability of A and B is equal to the probability of A given B times the probability of B. And if they're independent, it's just the probability of A times the probability of B. So if they are independent, then we don't have to worry about the probability of A given B. So we've kind of already alluded to this multiplication rule earlier. The addition rule we've already introduced in a little bit other examples in 3.2. So it says if A and B are defined on a sample space, then the probability of A or B can be shown by taking the probability of A plus the probability of B and subtracting the A and B, which is the overlap, which we kind of talked about in lesson 3.2. So we're going to experience that again. If A and B are mutually exclusive, which we just talked about in lesson 3.2, then the probability of A and B is equal to 0. So there is no overlap. In that case, the probability of A or B is simply just the probability of A plus the probability of B because there is no overlap. Well, let's look at a few examples. Klaus is trying to choose where to go on vacation. His two choices are A, New Zealand, or B, Alaska. Klaus can only afford one vacation. The probability that he chooses A is 0.6, and the probability that he chooses B is 0.35. The probability of A and B is 0 because Klaus can only afford to take one vacation. Therefore, the probability that he chooses either New Zealand or Alaska is the probability of A or B, which is just the probability of A plus the probability of B, which is 0.6 plus 0.35 is 0.95. Note that the probability that he does not choose to go on vacation anywhere must be 0.05 because it has to add to make 1. So let's look at it. So it says Carlos plays college soccer. He makes a goal 65% of the time he shoots. Carlos is going to attempt 2 goals in a row in the next game. A is the event Carlos is successful on his first attempt. The probability of A is 0.65. B is the event Carlos is successful on his second attempt, and that probability is also 0.65. Carlos tends to shoot in streaks. The probability that he makes a second goal given he made his first goal is 0.9. Okay. So this last statement here is the probability that he makes his second goal. So B given A happened is 0.9. What is the probability that he makes both goals? Wow. So his probability of A given B. So we said the A and, so this would be the probability of A and B. We don't know if they're independent, so we have to say the probability of probability of B given A, right? the probability that he makes the second goal given that he made the first one. So it'd be the probability of B given A times the probability of A. So that would be 0.9 times 0.65. And that is 0.9 times 0.65 is 0.585, which is 58.5%. Let's answer the next question. It says, what is the probability that Carlos makes either the first goal or the second goal? So, or would be the probability of A plus the probability of B minus the probability of A and B, the overlap. So the probability of A was 0.65. The probability of B is also 0.65 minus the probability of A and B, which we just found in the first part. So 0.585. Is equal to 0.715, so 71.5%. Are A and B independent? So if they were independent, then we could just multiply 0.6 times 0.6. So no, they are not independent. Because if they were, then the probability of A and B would be equal to the probability of A times the probability of B. But we know the probability of A and B is 0.585, and the probability of A times B would be 0.65 times 0.65, which equals 0.4225. And these two do not equal each other. So they're not. Look here, it says, Helen plays basketball. For free throws, she makes a shot 75% of the time. That's pretty good. Helen must now attempt 2 free throws. C is the event that Helen makes the first shot. The probability of C is 0.75. D is the event that Helen makes the second shot, and that probability is 0.75. The probability that Helen makes the second free throw, given that she made the first one, is 0.85. What is the probability that Helen makes both? So the probability of C and D is equal to the probability of right here. So we have to use this given. Probably that she makes the second one, given that she made the first one, is 0.85. So we need the probability of D given C times the probability of C. And so we have 0.85 times the probability of C, which is 0.75. 0.85 times 0.75 is 0.6375. So about 63.75% of the time that she makes C and D. She'll make the first one and the second. A couple more. So it says a school has 200 seniors, of whom 140 will be going to college next year. 40 will be going directly to work. The remainder are taking a gap year. 50 of the seniors going to play 50 of the seniors going to college play sports. 30 of the seniors going directly to work play sports. 5 of the seniors taking a gap year play sports. What is the probability that a senior is taking a gap year? Okay, let's just look at these. So we have 200 seniors total, right? And that is made up of 140 of them are going to college. Trying to organize this. 40 are going to work. So that means we have 20 left, 180. So 200 minus 180 is they're taking a gap year. So that would be 20. They're taking a gap year. Okay. Then it says 50 of the seniors going to college. So 50 of these seniors here are going to play sports. So 50 are sports. That means 140 minus 50 is 90 is no sports. They're not playing sports. 30 of the seniors going directly to work play sports. So that means 30 are playing sports. And that means 40 minus 30 is 10 are no, they are not playing sports. 5 of the seniors taking a gap year play sports. So 5 are playing sports. And that means 15, right? The complement, 20 minus 5 is 15 are no sports. Okay. So our 140 plus 40 plus 20 should get us to 200. And then all of our red numbers should also get us to 200. So 50 plus 90 plus 30 plus 10 plus 5 plus 15. Yes. So they want to know, what is the probability that a senior is taking a gap year? A gap year is just 20 out of 100. So probability of gap year. Which is 0.1 or 10%. We didn't even need to know if they were playing. Okay. A student goes to the library. Let events B equal the student checks out a book, and D is the student checks out a DVD. Suppose that the probability of B is 0.4 and the probability of D is 0.3. The probability of checking out a DVD, given that they've already checked out a book, is 0.5. Find the probability of B and D. So by our definition from the beginning of this lesson, that means this is the probability of D given B times the probability of B. It has to be this one, the probability of D given B times the probability of B. Okay. So we know D given B is 0.5 times the probability of B is 0.4. So 0.2, 20%. Find the probability of B or D. So that means the probability of B plus the probability of D minus the probability of B and D, because there is overlap. We can see that here in part A. So the probability of B is 0.4 plus the probability of D is 0.3 minus the overlap is 0.2. So 0.4 plus 0.3 minus 0.2 is 0.5. So about 50%. Either check out a book or check out a DVD. And that is all for lesson 3.3. Catch me that for lesson 3.4.